All right, I'm going to walk you through the day 7 worksheet. So first up, you want to go back to day 5. So you can get out of your assignment and open up the spreadsheet from day 5. You can open up another tab and do that. We're going to need these two numbers from at the bottom of the watt hours for day and the bottom of the watt hours for night. If either of these numbers is bigger than 250, you need to fix that first. They can't be more than 250. Okay, so I'm going to look. I think I'm asking you on the other sheet. Let's take a look. The instructions are all right here. From the day 5 Google Sheet, find the night watt hour total and enter it here. So the night watt hour total on my sheet is 125. So I'm going to enter 125. And sheet automatically doubles this, so you don't have to type anything there. I'm telling you, we double this because night usage requires batteries, and we never want to run our battery down more than 50%. So I have it automatically put 48 in if your number was smaller than 48, just because we want to have a little bit of a battery on every system. All right, batteries are rated in amp hours. We learned that before. To convert watt hours, double the watt hour. We're going to convert watt hours to amp hours, we divide by 12 because it's a 12-volt system. So I automatically do this for you. 250 divided by 12 is 20.8. So we need at least a 21 amp hour battery. Next, we're going to calculate solar panel requirements. To do this, we need the day watt hours value from our sheet. So day watt hours is 220 over here. 220. All right. And then to determine the size of the solar panel we add up both the daytime and nighttime loads. So that's 220 and 125. And where are we? Right here. 220 and 125 multiplied by 2, and then we divide by the number of sun hours. And it depends on where you live, what part of the world. But we're going to estimate. I have an example here for Berkeley. There's 3 hours of sun in the winter and 6 in the summer. We're going to just say 5 all year round because that'll take care of. Sometimes we have more, sometimes we have less. So, and then the reason we multiply all the loads by 2 is that, a system like this is not perfectly efficient. So anyway, I do all the calculations for you right here, and you don't have to enter anything. It's automatically done. And then finally, we need to figure out what kind of charge controller to get. Charge controllers are rated in volts and amps. We're using 12-volt systems, so that part is already set. Charge controller needs to be able to handle all 125% of what the solar panel is going to be doing. So we take our solar wattage above, divide by 12, and then multiply by 1.25 to get the minimum charge controller amps. So 14.4 amps automatically calculated. Okay, so then down here, these values are automatically all entered from up above. You see the 14 is right here, but the 138 came from I saw it. Where is it? Right here. Well, yeah. It's just getting popped by. Okay. Anyway. So here's the numbers. And hang on. Okay. So anyway, these numbers are all entered for you automatically. All we really had to enter was the night hours, night watt hours, and the day watt hours. And then these are our numbers. So this determines what we need for our system. So to get a battery, what we need is, I've got a parts list, so we can click on this thing and open up a new tab. It shows a PDF, and I put a bunch of batteries in here. I mean, you could obviously shop around, but might as well, let's just use my thing. We need at least a 21 amp hour battery. So we're going to take a look here. We're looking for the AH, that's amp hours. This is 7.5, 8.5, 14. Here's 21. So we're going to go ahead and put that one down, and we don't have to write all that information. What I want you to do is down here say 21 amp hour battery. Let's put 21 here, and the cost was $58.95. So Back here, 58.95. All right. And then solar panel watts required, 138. So if we scroll through this document, you don't have to open another copy. We need at least 138 solar watts. And here's a 150 watt panel, and it costs $138. So down here on solar panel, we're going to say 150 watt solar panel. It's 150 watts, and it's $138. All right, let's see, it's adding up the total cost of the system for us. And then finally, for the charge controller, here I'm going to make the everything a little smaller so it shows. Charge control has to be at least 14.4 amps. So probably we're looking for a 15 amp charge controller. And if you scroll down here, I've got charge controllers here. Here's a 15 amp charge controller for $100. So you don't have to write all the details down. Just say 15 amp charge controller, 15, and I think it was $100. I'm gonna go look. Remember all the numbers? Yeah, $100. And so there you go. That's it for the solar project. I just put 3 links here there to the same document. But the idea is, of course, if you were going to build this, there'd be some other parts, like you need some sort of case. You'd need probably a circuit breaker or some fuses so that the system would be safe in case of, some sort of problem. Some switches, some wires. You'd also have to pay for tax and shipping. So, realistically, this probably would end up costing $400 or $500 total. The one I've just laid out here, but that's the deal. So turn in this sheet. I hope you enjoyed figuring out what it would cost to run some of your things if we had a budget. It's too bad we don't have a 500 per student budget to build these things. That would be the ultimate. But anyway, have a great day. Thanks. Let's see, I got to turn it off up here.